Hey guys, today is March 18th and I'm going to do another LeetCode daily challenge. So yesterday's problem was quite tricky for me, but I think I'm learning some more stuff about bitwise operations. So let's go. Today is minimum operations to make binary array elements equal to 1. Okay, you are given a binary array nums. You can do the following operation on the array any number of times, possibly 0. Choose any 3 consecutive elements from the array and flip all of them. Flipping an element means changing its value from 0 to 1 and from 1 to 0. Return the minimum number of operations required to make all elements in nums equal to 1. If it is impossible, return -1. Okay. I thought, so this is a binary array of just 0 and 1s. Flipping is just literally flipping a 0 to a 1 and a 1 to a 0. And this operation is choosing 3 consecutive elements and flipping all of them. So choose the first 3 to flip, so it's 1 0 0, 1 0 0, and then choose the index 1 2 3, which is 1 1 0, and then flip the last 3 so that it's all 1 1 1 1 1. This seems like just reading this problem, I don't know if there's a good way to know what to flip. Like, how did we know that flipping these first 3 is the most optimal decision? So I think that's kind of a hint that we're not supposed to know. Like, why didn't we flip this? Like, if this is 1 0 0, why didn't we just flip this 1 0 0, right? And I guess it could come down to that means we need some more information down the line. And oftentimes that means we need some sort of like dynamic programming or memoization, right? So I think I'm gonna try to use like caching memoization to solve this problem, but we'll see. I'll at least try that. So what that requires is for me to have a function called min_ops, like minimum operations required. And all we need to do is just return min_ops starting at 0. And then I just want to say n is the length of nums. And this is going to be probably where we start the flip, right? The start index of where we're flipping. The start index, that means we're going to be flipping, if it's min_op 0, that means we could flip these 3. And then with all of these like memoization things, I'm just gonna put cache for now. You kind of want some sort of exit case, and I'm thinking since we always want 3 consecutive, and if this is our start index, we want to only accept 1 2 3 4 5 6 0 1 2 3. So I think if start index is greater than or equal to n minus 3, then we could just return 0. Let me see. Wait, actually, let me think a little bit more because it doesn't seem right. Okay, scratch all of this DP. I don't think it's gonna be dynamic programming. It just doesn't seem like that would work. I don't know. Maybe if I see a 0, I should flip it right away. So if I see a 0, I flip. So I flip that, and then that's one operation, right? Then I go to the next 0 that I see, and then I flip it. So that's gonna be like this. Oh, sorry. I flip, and then those stay the same as 0. Then I can flip the next 0, so it'll be 1, 1, 1, 1, 1, 1. I think I would want probably a better test case because this is just saying like every time I see a 0, just flip it. So let's try this one. If I flip starting from this index, because it's a 0, I would get 1, 1, 1, 0, 1, 0, 0. And then I keep going. Why don't I flip starting from this one? So I need to flip these three. 1, 1, 1, 1, 0, 1, 0. Then I need to flip these three. 1, 1, 1, 1, 1, 0, 1. And then, was this possible? Okay, so this was impossible. Okay, that was impossible. 0, 1, 0. 1, 1, 1, 0, 0. How? I feel like I'm just making a bunch of test cases. I don't know. Whatever, I guess this is part of it because I don't have a concrete idea. The only concrete idea I have right now is I just traverse left to right. If I see a 0, I just flip. So let me flip these three. 1, 0, 1, 1, 1, 1, 0, 0. Let me flip these three. 1, 1, 0, 0, 1, 1, 0, 0. Let me flip these three. 1, 1, 1, 1, 0, 1, 0, 0. Let me flip these three. 1, 1, 1, 1, 1, 0, 1, 0. And then finally flip these three. 1, 1, 1, 1, 1, 1, 0, 1. And then it's impossible. Oh, what am I doing? So, maybe most things are just impossible, to be honest. But I would like to find a test case that makes it actually possible. But like, how do I create an example? Ah. Okay, well, at this point, I guess I'll try doing that. Damn, why can't I think about it better? So n is the length of the nums for I in range n. Is it n minus 2? If nums I is 0, flip the next 3. Or flip the current and next 2. Nums I is... Wait a second. Whatever. I just need to flip it, I guess. So if nums I equals 0, nums I is equal to 1, else nums I is equal to 0. For I in range 3, if nums at I plus I plus I plus II. You have to flip the next two. That means our min ops needs to go up by 1 by the end of check if all are 1. So if they're all 1, just return the minimum ops. Otherwise, return -1. Ah, this is disgusting. Oh. Interesting problem. I have very little confidence. The reason why I just coded this was because I really couldn't think of any test case. So I wanted to get it wrong so that it would spit out like more test cases for me to use. But okay, what this means is that there's probably a proof, or if I thought about it harder, there's probably a reason why the first 0 we see, we should flip it. And I mean, huh. So yeah, I think I still have some doubts. Like, why would I flip these 3 when maybe I could flip these 3 and it would be better? Like, if I flip this one, it'd be 1 0 1 0, and then that would go nowhere, right? I guess a 0 1 0 will just never be good. Huh. Yeah, anyways, I don't know. I'm not really happy about this problem, but it's cool that I did it. Um, I'll definitely have to look at a reason why it works that way. But let's talk about time complexity. This is just linear, and then even though there's another for loop in here, it's just running like a set amount of times, 3 times. So this is just constant. So it's really just linear, right? O of n. And then checking all of nums is also O of n. So everything is just O of n. Space, we are just using the nums that are given to us to change the values of it. So that's constant space, right? We're not allocating a new array. Anyways, hope you guys enjoyed this video and see you tomorrow.